My dear student, I am Devendra Vasadi, Department of Physics. So, let us discuss the new chapter of rotational motion in 12th science in physics subject. Now here, in this year, the syllabus of 12th science is tremendously changes. I found it. In old syllabus, this chapter has name rotational motion and here changes into rotational dynamics. What is meant by dynamics? Dynamics means it is a branch of mechanics in which we deals with the study of motion of object. Because if you want to study the motion of object, in physics it is a special branch. A name of that branch is a original branch is a mechanics. And mechanics again classified into three categories. Number one, kinematics, number two, dynamics, and number three, statics. Means dynamics is the second branch of mechanics and mechanics is the branch of physics. It means dynamics means motion, dynamics means power, means here rotational motion, that means rotational dynamics. When the rigid body perform rotational motion, at the same time particle inside the rigid body perform circular motion. Means all the circles traced by the particle, its center, all the center of circle passes one imaginary line. That name of imaginary line is the axis of rotation. Means axis of rotation means the imaginary line passes through the all the center of circles of particle, and body perform rotational motion. At the same time particle inside the rigid body perform circular motion. Means there is two motions simultaneously takes place. One is that rotational motion and second one is that circular motion. And here what is meant by circular motion? The motion of the particle or motion of the object along the circumference of circle. Means condition of circular motion is particle moves along the circumference of circle. That is called as a circular motion. This circular motion have some characteristic. Let us discuss. The first characteristic of circular motion is a accelerated motion. Means circular motion is an accelerated motion. Why it is accelerated motion? When the particle performs circular motion, this particle has acceleration. Which type of acceleration? Centripetal acceleration. Why it is called as centripetal acceleration? Because acceleration of the particle is directed towards the center of circle. So it is called as a centripetal acceleration. And another name, that is the radial acceleration. Why it is called as radial acceleration? Because its acceleration directed along the radius. So it is called as a radial acceleration. So circular motion is an accelerated motion because particle has acceleration in circular motion. And second characteristic is that periodic motion. Means circular motion is a periodic motion. But what is meant by periodic motion? The motion which repeat itself after equal interval of time. That can be understood by considering the one example. Let us consider the example of electron revolving around the nucleus. Means electron repeats its motion after equal interval of time. Nobody pushed the electron to revolve around it. Means electron repeat itself. So it is a periodic motion. And these are the two important characteristics of circular motion. One is accelerated motion and second one is periodic motion. Now we have discussed here the next topic, that is the kinematics in circular motion. Kinematics. In kinematics in circular motion, for that purpose we consider here simultaneously two motion. One is the linear motion and second one is a circular motion. When the body or particle perform linear motion, some physical quantity involved like displacement, velocity, acceleration, momentum, force, all these are the physical quantity involved in that motion. But when the body performs circular motion, there are some physical quantity like that of angular displacement, angular velocity, angular acceleration, angular momentum, torque. All these are the physical quantity involved. Means the displacement in linear motion is analogous with the angular displacement in rotational motion. Means x is analogous with the theta. Velocity in linear motion is analogous with the angular velocity in rotational motion. Means v is analogous with the omega, and v is the rate of change of linear displacement with respect to time, and omega is the rate of change of angular displacement with respect to time. That means v is equal to dx upon dt, or omega is equal to d theta upon dt. That means v is analogous with the omega. Similarly, linear acceleration denoted by small a, and linear acceleration is the rate of change of velocity with respect to time, and angular acceleration is the rate of change of angular velocity with respect to time. A is equal to dv by dt and alpha is equal to d omega by dt. Means a, small a, is linear acceleration in linear motion, is analogous with the angular acceleration in circular motion or rotational motion, that is alpha. This is the analogy in between the physical quantity involved in linear motion and physical quantity involved in rotational motion. Now there is a relation between v and omega. V is equal to r omega is the important relation in between linear speed and angular speed. It is not the relation between linear velocity and angular velocity. If we write vector v is equal to vector omega cross radius vector r, now this is the relation between linear velocity and angular velocity. Now direction of omega is always along the axis of rotation, and that is given by right hand rule. Mean direction of omega, direction of alpha, and direction of angular displacement, all these directions, all these physical quantities of its direction is given by right hand rule. So let us discuss about the right hand rule. Imagine the axis of rotation to be held in the right hand with finger curve around the axis and thumb stretch along the axis. Finger curve round the axis. Suppose this is our thumb. Thumb stretch along the axis, and this is finger. This finger curve around the axis. Now, if the finger indicate the sense of rotation. This is core finger. This core finger indicate sense of rotation, and the stretch thumb indicate direction of vector, means direction of alpha, direction of omega, direction of angular displacement. This is indicated by the stretch thumb, means this is the right hand rule. I repeat again, imagine the axis of rotation to be held in right hand with finger curve round the axis. This is finger, this finger curve round the axis and thumb stretch along the axis. If this curve finger indicate direction of rotation and the stretch thumb indicate direction of vector, this is a right hand rule. Now circular motion is classified into two categories. Number one, uniform circular motion, and number two, non-uniform circular motion. The base of this classification is that, I say here, base of this classification is that when the particle performs circular motion, at that time direction of velocity changes instantly, but magnitude of velocity, that means the linear speed, may or may not be constant. May or may not be constant, may be the constant or may not be constant. By considering this fact, the circular motion are classified into two categories. Number one, uniform circular motion, and number two, non-uniform circular motion. In uniform circular motion, the object moves along the circumference of circle with constant linear speed. Means, how to define uniform circular motion? The motion of the object along the circumference of circle with constant linear speed. So it is called as a uniform circular motion. If variable linear speed, it is a non-uniform circular motion. In uniform circular motion, the acceleration of the particle is that A is equal to r omega square. This is the centripetal acceleration, this is the radial acceleration. And this is why it is called a centripetal, because it is directed toward the center of circle, and radial, why it is radial? Along the radius, so it is called as a radial acceleration, and formula is that A is equal to r omega square. And if you write in vector form, vector A is equal to minus omega square radius vector r, and this minus sign indicate that direction of A and direction of r both are opposite, that can indicate this negative sign. Non-uniform circular motion, when the particle perform circular motion with variable linear speed, that is called as non-uniform. That means here the motion of object along the circumference of circle with variable linear speed, that is called as a non-uniform circular motion. Variable linear speed, that to be discussed by considering one example. When the fan is switched on or off, the speed of the fan goes on increasing or decreasing at the same time. जर आपण फॅन जो आहे तो सुरू केला, त्याचा जो स्पीड आहे तो सुरुवातीला वाढेल वाढेल वाढेल, म्हणजे सुरुवातीला इनिशियली तो स्पीड असा वाढत 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 जाईल, आणि ऑफ केला तर त्याचा स्पीड एकदम फॅन थांबणार नाही तर कमी होईल, म्हणजे त्याचा स्पीड हा व्हेरिएबल आहे. मीन्स हिअर द स्पीड ऑफ द ऑब्जेक्ट is a variable, so it is a non-uniform circular motion. Now let us discuss here the another topic, that is the dynamics in circular motion. If you want to discuss here the dynamics in circular motion, we see here two type of force. One is the centripetal force and another is a centrifugal force. What is meant by centripetal force? the force which acts on the particle towards the center of circle, that is called as a centripetal force. Means when the particle performs circular motion, the force acts on the particle which is directed towards the center of circle. That force is a centripetal force. And first, centripetal acceleration. Centripetal acceleration means the acceleration of the particle directed towards the center of circle, and this acceleration is A is equal to r omega square. In vector form, vector A is equal to minus omega square radius vector r. Now this centripetal force is a real force. Its formula is that Cf is equal to m r omega square. In vector form, vector F is equal to minus m omega square radius vector r. This is the centripetal force in vector form. This force is responsible for the circular motion and is a real force. Why it is real force? Let us discuss here. The force which originate from the fundamental force, that is called as a real force. There are the four fundamental forces. One is gravitational force, second one is electromagnetic force, third one is strong nuclear force, fourth one is weak nuclear force. Those force originate from any one of these fundamental force, which is called as a centripetal force. Here centripetal force is a real force. This force is originate from this fundamental force, which is called as a real force, not a centripetal. It is a real force. Means the main condition of real force is that it originate from any one of the fundamental force. Now let us discuss here the another type of force, that is the centrifugal force. The force which acts on the particle away from the center of circle. If it is away, it is a centrifugal. If it is towards, it is a centripetal force. Formula is same. The magnitude of centripetal force is exactly equal to the magnitude of centrifugal force. But there is a difference of sign. If you write the formula for the centripetal force in vector form, there is a minus sign. But if you write the formula for centrifugal force, there is no minus sign. Because centrifugal force and radius vector directed in same direction, so there is no negative sign, and it is a pseudo force. It is a imaginary force. This force does not responsible for the circular motion. That to be seen by considering the diagram on the screen.